Okay, in this video I'm going to talk about the curl. So this curl is also a important feature of the vector calculus. So I'm going to go through the basic definition of the curl. So if we have a vector field V, then the curl will be defined as del cross V. So V is my vector field. So in the previous video I have mentioned that I have defined this vector field V. So V is equal to Vx x hat and y hat and Vc c hat. So I'm not going to define it again. So now we have a cross product here. So you know that del operator is always a vector. So these are actually this actually a cross product between two vectors. So that means that we have to use a matrix format, or you can go through with the first you can go through with the uh, definition. So you have to use dab x, so dab over dab x hat, and dab over dab y hat. This is del operator. I'm writing the del operator. So now you have the cross product with Vx x hat and Vy y hat and Vc c hat. So this is my V vector. So now you have two vectors and the cross product between two vectors. So you can use the matrix format, or you can use the determinant format. So what you can do here is that you have x hat, y hat and c hat. So now you have the first vector. So the first vector is del operator. So the vector components should be written in the middle of this determinant. First vector is del operator. So the del operator is going to be, the component of del operator is going to be dab over dab x and dab over dab y and dab over dab c. So now we have the second vector. So the second vector is v. So the vector components are vx, vy and vc. So now we can calculate the determinant value of the matrix. So when you find that x hat times, you're going to forget this column and this row. So now you have four elements: w, wy, w, c and vy and vc. So this forms a matrix, and you have to get the determinant of these four elements. So now you have daba over daba vz over daba y, daba vc over daba y minus daba vy over daba c. So likewise you have minus y hat, because I have told you that when we have 3 by 3 matrix, you have to use this pattern, plus minus plus. So this is y minus y hat. So you have to forget this column and this row. You have four elements: w, x, w, z and vx, vy, vz. Okay, now I'm going to write the expression. I hope you can simplify these steps. Okay, now I have calculated the determinant value. So this is going to be the determinant value, and you are going to find the determinant of this matrix. So you are going to get a vector here. So because we have a vector product here, you can also call as the cross product. So when you have a cross product, it's the final outcome will be a vector. So now if you take a look at the representation of the curl, actually a geometrical representation of the curl, or you can say the real world experience of the curl. So actually if the vector field points like this, so actually this does not mean that we have a curl of vector field. So that means the curl of v is equals to 0, because curl is something called how much vector field is curls around a given point. So that means that if we have a point like this, when we have spreads out from the point, the vector field, let's say that the vector field is spreads out from a given point, so that means that we have a divergence, but the curl is equals to 0, because this does not mean that if the vector field is spread out from the given point, this does not mean that the given the given vector field is curls around a given point. So what you have to see is that for the practical for the practically, you can see that a whirlpool, you can see in a sink, the water gets curled. So what you can see is that the pattern will be like this. So this is just a curl. This is the given point, so this vector field is curls around this given point, so that means there is a curl. So when we have a vector field like this, so the curl is not going to be 0. So this is the geometrical representation of the curl. So I hope you understand these concepts really well. So if you have a question, please comment below. So I think I can move to the next part of this video series, which is going to be second derivatives of this kind of curls and gradients, because we only considered about first derivatives, because if you take a look at w z over w, this is always going to be first derivatives. So I'm going to talk about the second derivatives as well in the next video. So up to you. I hope to see you in the next video.